Welcome to Hexagon Tutorials Dart series. In this tutorial, we will explore the concept of encapsulation, understand its importance, and learn how it helps in structuring secure and well-managed code. Encapsulation is a fundamental concept in object-oriented programming that helps in protecting the internal details of a class. Instead of allowing direct access to variables, we restrict it and provide controlled ways to read or modify data. Now, why do we use encapsulation? First, it protects data from unwanted changes. Imagine if any part of the program could directly modify an object's properties, this could lead to unexpected behavior or even errors. Encapsulation prevents this by restricting direct access. Second, it allows controlled access to fields. Instead of exposing variables, we provide methods to access or update them. This ensures that data is always handled in a safe and structured way. Third, it helps in maintaining data integrity. Since we can control how data is accessed or modified, we can apply validation rules before making any changes. This helps prevent invalid data from being stored inside an object. In Dart, we achieve encapsulation by using private variables and getters and setters. A private variable is simply a variable that starts with an underscore, which makes it inaccessible from outside the class. But since we may still need to access or modify it, we use getter methods to retrieve the value and setter methods to update it with proper validation. So, in short, encapsulation ensures better security, control, and reliability of our code by restricting direct access to data while still allowing necessary modifications through controlled methods. Here, we have a class called person. Inside this class, we define two variables. First, we have name, which is a public variable, meaning it can be accessed from anywhere. Then, we have underscore, which is a private variable, meaning it can only be accessed within this class. Now, to display these values, we create a method called display, which prints both the name and underscore values. Moving on to the main function, we create an object person from the person class. Since name is public, we can access and print it without any issue. But when we try to print underscore directly from outside the class, we get an error because private variables cannot be accessed outside their class. However, when we call the display method, it successfully prints underscore because private variables are accessible within the class itself. Alright, let's break this down step by step and understand how encapsulation works in Dart through this bank account example. We have a class called bank account, and inside this class, we declare a private variable underscore balance, which is used to store the account balance. The underscore before balance makes it private, meaning it cannot be accessed directly from outside the class. Now, since the balance is private, we need a way to access and modify it safely. This is where getters and setters come into play. First, we have a getter method called balance. This allows us to read the current balance of the account without modifying it. Then, we have a setter named deposit, which allows us to add money to the account. But notice the condition inside the setter. If the deposit amount is greater than 0, it adds the amount to the balance. Otherwise, it prints invalid deposit amount, preventing negative deposits. Next, we have a withdraw method that allows money to be withdrawn. Before deducting the amount, it checks if the account has sufficient balance. If the balance is enough, the withdrawal is successful. Otherwise, it prints insufficient balance to prevent overdrawing. Now, let's see what happens in the main function. We create an object called myAccount from the bank account class. Using the setter, we deposit 1000 into the account. We print the balance, which now shows 1000. Then, we withdraw 300, which reduces the balance to 700. Finally, we try depositing a negative amount, minus 500. But since our setter checks for negative values, it prevents this transaction and displays invalid deposit amount. Now, let's look at the output of this program. Current balance, 1000. Balance after withdrawal, 700. Invalid deposit amount. So, what did we learn? Encapsulation ensures that underscore balance is protected and cannot be accessed directly. Getters allow safe access to private data. Setters help control modifications, ensuring only valid data is entered. Encapsulation improves security by preventing unauthorized changes to important variables. And that's how encapsulation and data security work in Dart. Let's understand how encapsulation works in this temperature class. The class temperature has a private variable underscore Celsius, which is used to store temperature in Celsius. Since it is private, it cannot be accessed directly from outside the class. To manage this, getters and setters are used. There's a getter and setter for Celsius. The getter returns the current Celsius value, while the setter allows modifying it. Similarly, there's a getter and setter for Fahrenheit. The getter converts the Celsius value to Fahrenheit using a formula, and the setter takes a Fahrenheit value, converts it to Celsius, and updates underscore Celsius. In the main function, an object temp is created from the temperature class. The Celsius setter is used to set the temperature to 25 degrees. When printed, it shows 25 degrees Celsius and 77 degrees Fahrenheit. Next, the Fahrenheit setter is used to set the temperature to 98.6 degrees Fahrenheit. Since the setter converts it to Celsius, the updated Celsius value is printed as 37 degrees. Let's do a quick recap of what we've learned about encapsulation. Encapsulation is all about protecting data and allowing controlled access to it. Instead of exposing variables directly, we use private variables by adding an underscore before their names. This ensures that data cannot be modified accidentally from outside the class. To access private data safely, we use getters and setters. Getters allow us to read the value of a variable, while setters let us modify it in a controlled way. One of the key benefits of using getters and setters is that we can add logic to them. For example, we can validate data before updating a value or format it before returning it. We can also create read-only properties by defining only a getter, meaning the value can be accessed but not modified. Similarly, write-only properties can be created using just a setter, allowing updates but preventing direct access to the value. And if a variable is not initialized immediately but will be assigned a value later, we can use the late keyword to handle it properly. So, encapsulation helps in data security, better control, and maintaining a structured way of accessing and modifying data in Dart. Thanks for watching. Stay tuned for the next part. And don't forget to like, share, and subscribe.